Okay, so good afternoon, everyone. Welcome to Uptake CDR monthly webinar series. We are very pleased to have a very nice panel today and very good discussion. Looking forward to it. I will just start with a very brief introduction of who we are and what we are working on, and then I will hand it over to Livia, who will moderate this session. I have just a couple of slides I'm going to share with you. Yes. Okay, let's go here. So as I mentioned, we are part of the monthly webinar series that is organized by Uptake. It is organized by CMCC with the help of our colleagues at Reform Institute, which are partner in the Uptake project. It is the second Wednesday of every month. We are holding these webinars at 2 p.m. Central European Time. To participate, you need to register. We will send reminders for people who have registered previously or they are members of our stakeholder community, but you will receive emails through different channels, CMCC, LinkedIn page, or other mailing list that you are member of. This is also part of the Industrial and Planetary Carbon Cycle program at CMCC. I will mention it a little bit further in this slide. So at CMCC, we are a research institute basically based in Italy. We have representations in different cities in Italy. Overall, we have about 450 researchers across 3 institutes. So the institutes are the one basically in focusing on environmental economy, one in climate resiliency, and one on Earth system modeling. We also have 3 cross-cutting programs. So I mentioned earlier that this kind of webinar is part of the integration of planetary and industrial carbon cycle program. We have 2 other programs predicting socioeconomic impacts of climate change and global coast as a new frontier. Uptake project is a European Horizon funded project. It has about 20 partners that you can see on the right side listed, different institutes and universities across Europe. It has started in September 2023 and it will go until August 2027. The total budget is 7 million. The aim of the project is to investigate the upscaling of various CDR technologies. We have developed a platform for interacting with outside stakeholders. So if you would like to hear more about the project outputs and get more informed about what we are working on, you can scan this QR code. There is a very easy, simple registration form. And after that, you will receive a link to join the platform, which is shown here on the left, how it looks like. We are regularly posting not only about the project, but also about what's happening in the world of CDR, all the updates in the business world and also in the research side. Today, we are very happy to host a webinar, which is going to talk about CDR science from the publications to development in terms of technology and policy and media and how it is being picked up by different stakeholders. The speaker is our colleague, Francesco Lamperti, who is our colleague at CMCC, but also a professor at Sant'Anna School of Advanced Studies in Pisa, Italy. We are happy to have panelists, Mark from Bellona and Christina from InPlanet. The moderator is Livia from Aarhus University in Denmark. And just to remind you, if you like to interact with the speakers and the panelists, please use the Q&A option at the bottom of your page. You can find it there. And stay tuned for the next webinar, which will be on July the 9th at 2 p.m. We will skip August because of holidays in Europe, and we will come back after next one after July. We come back in September. So having said that, I will leave it to Livia to moderate the panel. Thank you very much.
Thanks a lot, Sohail, for this introduction. Welcome, everybody, also from my side. I'm Livia Fritz from Aarhus University, which is one of the partner institutions in the Uptake project. And I have the pleasure of guiding you through this next hour. I want to first thank our Uptake coordinators and colleagues at CMCC for hosting this webinar series, and also our colleagues at Reform Institute for putting together the program of today on spillovers from CDR research into technology, media, and policy. We have an excellent mix of speakers from across academia, the private sector, and civil society with us today, so we'll really get a chance to take various perspectives on those spillovers. A couple of quick information before we get started. We will first have a 20 minutes presentation, and I'll briefly introduce our speaker in just a minute. And we will then follow with a 10 minutes discussion with our two invited panelists. And that will leave us then with roughly 15 minutes at the end for an open discussion with all of you. And I'd like to encourage you already now to put your comments, thoughts, questions in the Q&A box throughout the session, and then I will bring them up with our speakers later on in the discussion. Okay, so let's turn to the presentation. I'm pleased to introduce you to our speaker today, Francesco Lamperti. Francesco holds a PhD in economics. And as Sohail was just saying, he's now a full professor at Sant'Anna School of Advanced Studies and also a scientist at CMCC. And he'll talk to us about a recent paper that he's co-authored in Environmental Research Letters on the public use of early stage scientific advances in carbon dioxide removal. If you have questions of clarification for Francesco, please share them in the Q&A while he speaks, and I'll try to bring them up with him later on. Okay, so Francesco, without further ado, the floor is yours.
Thanks a lot, Livia. Thanks, everybody. Thanks, Sohail, for the kind introduction, and many thanks also for the invitation. Very happy to discuss a recent piece of my research with you. First of all, can you hear me well? Okay, great. So I'm sharing the screen. Okay. Okay, so in the next 20 minutes, I'll try to give you an overview about a recent research piece that we put together. And the idea of this research was to start from basic research from papers, scientific papers published within the realm of the various CDR methods, trying to understand how it's possible to build on this stock of knowledge, moving pieces of knowledge from science to science itself, so a sort of science to science flow of knowledge, but also to technology, policy, and media for different kind of carbon removal solution, and trying to assess whether there is a sort of coherent picture emerging from how CDR-related knowledge flow from science again to technology, policy, and media. As Livia was anticipating you, this is taken from a paper which is a joint work. So I'm particularly willing to underline that this is a shared piece of work, and in particular, a good deal of the job was done by the first author, Giorgio Tripodi, who is also a friend, and is now at the Kellogg School of Management at Northwestern University. So let me start with the trouble with CDR, at least from one of the possible perspectives. So on one side, we know that CDR methods and the diffusion of negative emission technologies are likely to be essential in any future where we have an ambitious containment of cumulative emissions and then global warming. But there are issues that are well known with some of the CDR methods. On one side, some of those methods are not fully developed. The industry is still building up, and having the technologies at scale would require a lot of research, starting from the basic one to the applied, development, and finally deployment. On the other side, there are very heterogeneous solutions, and up to now, at least from my knowledge of the literature, but also the policy discourse, there is no agreement on a universally superior option. So especially when we have to think about region or country plans towards a CDR strategy, it's possible that we will need to couple different solutions. On the other side, we have possibly problematic economic incentives, starting from the usual problem of moral hazard and mitigation deterrence, but also to who has the economic incentive to really invest and deploy these technologies when we overcome net zero, when we go to net negative, for example. And so a legitimate question is, what is the role of public policies in dealing with these incentives toward the full chain, let's say, from research to the final deployment at scale, not only when we manage hard-to-abate emissions, residual emissions, but also when we'll need to go net negative. And on the other side, these technologies, they remain controversial. And I just highlight this piece of an article coming up in the New York Times yesterday, where again, there is part of this debate from different angles, the recent controversy on whether Climeworks is delivering or not, what are the risks for this technology, and this is obviously communicated to the public. So trying to understand how the public reacts to this debate is also important to then run public policies that are effective. So this is a little bit the context, and in this context, what we witness is an increasing interest in CDR method and an increasing research activity. Here you find the, let's say, long-run evolution of scientific articles that are identified thanks to a keyword-based approach that we brought from the literature across different methods. And you see a sort of exponential trajectory, which obviously continued after 2017. I'll be back later on why we stop on 2017. And the idea is that we want to measure again this spillover. So we want to see how these scientific articles are then used to build up technologies, to inform policymakers, to inform the public about the existence and the role of CDR. When we look instead at the geographical distribution of these papers, here we are not normalizing by anything, so we don't correct by size, but it's clear that there are a few hotspots for research in this in CDR, and one is obviously the US. On the other hand, you have Europe, but also Australia and China. And when we moved to the city level perspective, we noticed that the city with the universities and research centers that contributed the most to CDR research was actually Beijing. And when we try to distinguish between novel, so for example, Beck's, biochar, DAX, and more conventional methods, what we notice is that there is a high interest in novel approaches. That is also building up through time. Why is it important to study the role of scientific research and how scientific research moves to policy, to technology, to media? Because of the ability of science to deliver on the grand challenges that we currently face. And I mean, putting, let's say, the Paris Agreement within reach, or keeping the Paris Agreement within reach, is obviously a public challenge. This is taken from an editorial in Science now a few years ago. And this basically says that the ability of science to deliver on its promise of practical and timely solution to the grand challenges does not just depend on the research accomplishments themselves, but also now the society, taken as at large, is able to receive the implication of scientific discoveries, to invest on it, to create an agreement about the need or not of these technologies that might develop starting from basic research. So what our paper tries to do is relatively simple. So what we try to answer is the following question. So does CDR research produce useful pieces of knowledge? And here the key word is useful. What we mean by useful is what is typically referred in the economics and economics of innovation, management of innovation literature as a spillover. So a spillover is typically defined as a flow of knowledge that is not directly mediated by markets. And one typical way to measure these spillovers is through citations. So leveraging, for example, on the fact of how many times a paper, a piece of basic research is cited into the scientific literature that is reviewed in patents. And in this way, we basically construct the science to technology link. But of course, beyond patent, we can also look at citation by policy documents, citations by media outlet, citations by social networks. And in this way, what we can understand is whether and how papers within the realm of CDR methods are then reused in science. For example, if we find a science-to-science citation, so a classic citation between papers, or whether this research is transferred into actual technological applications. So how and if the focal paper is cited into patents, into policy documents, so we can test whether research in CDR can also inform policy, and then finally whether it is disseminated to the public. And then what we try to do is to answer a second research question, which is the following. We try to understand whether these spillovers are coherent across the different dimensions. So let's say whether they are coherent in the spectrum that is broadly defined by the science, technology, policy, media nexus. So this is the purpose of our paper, and we do this by focusing on what we call the sort of first wave of CDR research. So what we did is to focus on the scientific production on CDR methods, including many of them. I'll show you something more later on, up until 2017. One of the key reasons for which we stopped in 2017 is because then what we need to understand is how these papers that are, as I showed you, mostly produced between early 2000s and 2017 are then cited into other documents, other papers, other patents, other policy documents. And so we need basically the period going beyond 2017, so the last, let's say, 5 years, in order to understand whether this knowledge that is produced as basic research is then translating into something that is useful for technology to inform the public, but also the policy documents. What are the sources? The data sources to do this. So for scientific articles, we rely on Web of Science, one of the largest data sets for this kind of particular documents, scientific papers. And then for citation from patents, we focus on 2 data sets. The first one is Reliance on Science, which is basically a data set that has been assembled by a group of researchers that then publish the data set and the analysis on the data set in the Strategic Management Journal, one of the leading journals in management studies, trying again to assess what is the contribution of basic science to different technological fields. And we also look at the data that Altmetric is providing us, so the link again between patent and papers to Altmetric. But ultimately, what Altimetric is very useful for us is to account also for the policy and media perspective. So Altimetric is typically the count of mentions that scientific papers obtain, and it's typically advertised in any website of the different journals. And Altimetric counts mentions across a number of outlets, including policy documents and media and social networks. So this is the first thing we do. We identify CDR research papers, and then we count basically the mentions that these papers they receive from other outlets. Again, patents, policy documents, media, including both news and social networks. And then what we try to do in order to assess the relevance of this, because of course we will find some positive number for these flows of knowledge, what we try to do is to match the set of CDR papers that we have with other comparable groups and see whether CDR research papers they produce more mentions, more citation, more knowledge flows than the comparable set of papers. And to do this, what we do is the construction of a series of control groups through a matching procedure. We divide these in two parts. So first of all, we try to focus on the two variables that, according to us, they best reflect the pattern of spillovers. This is also informed by the literature, obviously. So we select papers that are not on CDR, but they are published in the same year and in the same venue. So for example, they are published in, let's say, carbon management and in the same year, but are not about CDR, or they're published in Nature Climate Change, same year, but not on CDR. And what we do next is to focus only on climate-related articles, climate change-related articles. And again, this is done by sub-selecting the set of all papers that have been published over the years through queries that have been taken from the literature. And of course, those are not the only two dimensions across that we control for. And in the regressions that then we run in order to estimate these spillover effects, we then control for a number of additional factors that might act as confounders. And then we construct basically 10, 20, I think in the final published version is 20 matching, 20 control groups, 20 matched samples, to which the focal set of CDR papers are compared to in terms of the spillovers, of the mentions they generate. Okay, first results. What we get is evidence of large spillovers from CDR research. Here, it's just a count, the simplest possible thing. So a relative number of mentions across many different outlets, many different dimensions. We also divide between conventional and novel methods. And the dashed line, it basically represents the control group. So if we find something which is beyond 1, above 1, it's because we have a positive spillovers. So we have a higher number of mentions with respect to the control group. If we find something which is below 1, so let's say between 0 and 1, it's because we have less mentions. So overall, what do we get? Evidence of large spillovers. So this research that is produced in CDR methods is more cited in news, so blog, news, but also Twitter, than the control group. Then let's say other papers with the same characteristics on and also focusing on climate change issues. Within the science, it is producing more citations. So we build more, scientific community builds more on these papers than on papers with similar characteristics, but in other fields. And also policy documents, they really try to focus more on these papers than what they do on others. The only dimension in which we have a different figure is patents. So here we have a difference between conventional and novel methods. So if we focus on novel methods, the picture is still coherent. So these papers are flowing into actual technological applications more than counterparts. But if we focus instead on conventional, this is less. And keep in the back of your mind, for example, for afforestation and reforestation or soil carbon management practices, we are focusing on the same journals. So journals that are typically focused on similar issues. So overall, what we find is evidence of positive and relatively large. Look at these numbers. It means that dimensions are 2-3 times larger. So large spillovers across all dimensions, with conventional methods receiving more attention typically, but for technological application. Here, instead, we focus on novel technologies, yes. So if we focus on DACs, BECS, biochar, enhanced weathering, yes. Otherwise, no. It's actually quite the relationship between science and technology is much weaker than for the control group. However, as I told you, they were simply counts without controlling for possible confounding factors. And so what we did is to enrich our model in order to test the probability of being mentioned with respect to the control group, also controlling for additional factors, which is, for example, the number of co-authors, the international team of co-authors, their publishing history, their relationship, their established relationship with let's say the business environment through science technology collaborations, so citations of other articles of them. And by controlling for some of these additional elements, at the end of the day, we get a relatively similar picture. So evidence of large spillovers, but for the technology. So even if we control for additional elements, still the picture is similar. And then let me focus a bit on the differences that we can find between the different CDR methods. Here, we are not super granular, so we have afforestation, reforestation, BECS, biochar, blue carbon, direct air capture, enhanced weathering, ocean fertilization, and soil carbon sequestration. And here you find the same results, but unpacked by CDR method. I would stress 2 results. The first one is on BECS. So we notice very large spillovers in policy documents and media, which basically mean policy and media, they are talking a lot about BECS, more than for other, especially media, for other CDR methods, and definitely more than the control group. But when it comes to whether BECS research is producing spillovers within science and also from science to technology, the evidence is very limited, or it's either almost negative or non-significant. So basically, we don't find evidence of significant spillovers from science to technology. When we focus instead on DAC, what we notice is that at the end of the day, DAC is the only method showing large, significant, and positive spillover across all dimensions. For others, what we find is an incoherent pattern. Either policy and media are very focused on them, but they lack spillover, significant spillover on science, on technology, or the other way around. Then what we did was also to try to assess how policy and media, they tend to talk about CDR research, and we did it in a very simple way. So of course, with this can be done in a much more sophisticated way. What we did is just to count whether media and policies they were mentioning, here it's for policy, so this chart is for policy, they were mentioning CDR related papers in a good or a bad way. with good and bad words identified with a very standard English dictionary. But what we find at the end of the day is that the policy environment is quite benevolent with respect to how it discusses CDR research, and we don't find any particular difference across the different methods. And this was a bit surprising for us, but this is at the end of the day, this is what we find. Again, this is unpacked by technology, and I wanted to focus on the fact that DAC is in a sort of unique position in the sense that it's the only method having positive spillovers for science, technology, policy, and media. And let me conclude by focusing on how this translates from a global perspective to a country or region-based perspective, which is at the end of the day where CDR strategies are developed. And here what we did is to start computing indexes of a relative advantage. Those are indexes of specialization. This is called the relative scientific advantage, which means what are the areas in which different countries are focusing their research. And here we focus on a subportion of all the countries. But for example, we can see some expected pattern. So an expected element is, for example, with Switzerland, which is focusing basically only on DAX. And of course, this is possibly reflected into the history also of Climeworks and the kind of research at the ETH. USA is differentiating between different approaches, both conventional and not. China is mainly focusing on conventional and nature-based approaches. UK, so if you look both at England here and Wales, they are kind of focusing on enhanced weathering. And so what we did is try to understand whether there are clusters around the world in which research is focusing, and actually we find a group of countries that are focusing on one method or another. And what we discover is that there is no, let's say, coherence. So some countries are focusing on some solutions, some countries are focusing on others.
Francesco,
so technology
may I
transfer,
ask you to wrap it up?
Just the last sentence, which also means that technology transfer, if we have a linear model of innovation, so starting from basic science, finally reaching the development of technologies, international technology transfer within CDR methods will be an issue. And this was my last slide. So thank you, and I'm sorry if I was a bit late.
Perfect. Thank you very much, Francesco, for this comprehensive overview of a very rich paper and analysis. If anybody has questions for Francesco, put them in the chat, and I would ask you, Francesco, to respond in written to any sort of clarification questions coming up. Okay, so let's move on to the second part of our webinar, and I want to introduce you to the two experts of our panel today. We have with us Mark Preston Aragonès. Mark holds degrees in international relations and also in climate change, development and policy from Sussex University. And he's now a senior policy manager at Bellona, an NGO working on climate change, where he is head of carbon accounting. So Mark is really perfectly positioned to talk to us about policy and societal spillovers of CDR research. Welcome, Mark. And I will get back to you after I've talked to our second panelist, who is Christina Larkin. Christina is a geochemist and a climate scientist. She holds a PhD from University of Cambridge, and she's now head of science and research at InPlanet, which is a CDR startup focused on enhanced rock weathering. Thanks also to you, Christina, for joining us today. And I want to start with you and focus a little bit on how you see the links between research and innovation or early stage deployment in your work. So if you sort of reflect a little bit on your experience as a head of science and research at InPlanet, what are the main challenges that you encounter in sort of trying to move from research into deployment? And do you have any ideas on, you know, what kind of policies or innovation systems would help address those challenges?
That's great. Thank you so much. Firstly, just want to say a big thank you for having me on this panel, and also to Francesco for a really insightful talk and a really interesting paper. I certainly learned a lot, so that was really nice to see. Just to answer your question, I think, as you mentioned, I work for an enhanced rock weathering company. We deploy in Brazil, and what we do is essentially spread rock powders on farmland, and that sequesters carbon. I think that for enhanced weathering, it has maybe slightly different challenges in comparison to other technological solutions like direct air capture, for example, because I think the typical trajectory for a technology might be a lab scale or benchtop process that you might then patent that process as well. And then you have to figure out how to scale it and get it to remove a meaningful amount of carbon dioxide from the atmosphere. I think with enhanced weathering, the process is actually somewhat reversed because deployment is actually relatively simple. It's an easier part of the puzzle because we have vast amounts of suitable rock powder available in quarries. It's produced as a byproduct as part of the normal industry that the quarries for aggregate and construction materials. They have fine material that's left over, typically left in piles and not used. And we can take that material and deploy it. We also have the infrastructure in place to do that. So there's transport available. There are spreaders available on farmland to spread that material. So deployment is quite straightforward. I think where the challenge comes in with science and enhanced weathering is more to do with the measurement of the carbon removal. Because it's an open system pathway, or what we call an open system pathway, we can't simply measure what comes in and what comes out. It's far more complicated than that. And so it involves a huge amount of measurement at the moment, and a measurement across multiple different phases and scales. And I think there's a lot of uncertainty as well involved in that quantification. And so where I see the main challenges of trying to get science integrated into our deployment is how we can do this measurement, reporting, and verification at scale, and how can that be cost effective? Because at the moment we're in a very research intensive phase, gathering lots and lots of data, quantifying rates and uncertainties at relatively small scales. And then when we scale up enhanced weathering, we need to bring the cost down of that measurement. We probably need to move to more model-based approaches for quantification, but we need to ensure that those models are robust, that they are transparent and verifiable. And so I think that's kind of where I'm most excited, but also where I see a lot of challenges.
Yeah, thanks so much for those reflections. I want to follow up briefly on what you were saying around MRV and sort of uncertainties. And for enhanced rock weathering, it might be around MRVs, and then for other technologies, it might be more on the scientific side of things or on the technological side. What's your sense of how we can sort of constructively engage with those uncertainties and also unknowns without sort of undermining public trust and also without losing momentum for deployment?
Yes, that's a really, really fantastic question. I would say it's a fine balance, but I think something that really helps to accelerate the whole field and to support enhanced rock weathering as a whole is transparency, actually. So just being transparent with your data, with your processes, being transparent about the uncertainty in your measurement, I think really does help to build trust. So something that we did at InPlanet, we actually issued the world's first enhanced rock weathering carbon credits at the beginning of this year. And what we did kind of consciously was made that data public. So that data and how we did that is public on the Isometric platform. It's a carbon registry. And on top of that, we have shared that data with a nonprofit called Cascade Climate, who have developed what they're calling an ERW data quarry. And this is a platform where academics can apply to access commercial deployment data sets and do research on it to help accelerate that field. And so I think transparency and shared learnings is really important at this stage. And it's something that InPlanet and myself are kind of very committed to doing that. I also think just being open about the uncertainties and taking uncertainty discounts. So something we did through the credit issuance process was, for example, we credited at 1 standard deviation below the mean, and we propagated all of our uncertainties in order to ensure that we had no chance of over crediting as well. So I think that's something that that can help accelerate the field is if you're just open about the uncertainty and then you incorporate that into your quantification as well.
Yeah, thanks. That's a very important point, transparency. If anyone in the audience have questions coming up for Christina or also Francesco, please feel free to put them in the Q&A. While you do so, I want to touch base with our second panelist and dive a little bit deeper into sort of CDR spillovers into policy or also society more widely. And in fact, Francesco was mentioning in his presentation how some methods or technologies like BECS, for example, receive relatively strong sort of policy and also media attention, despite sort of limited technological spillovers, at least if we're looking at patenting activities. Mark, what's your sense of those sort of mismatches or incoherences? Do you encounter them in your work? And if so, what kind of risks do you see sort of related to that?
Yeah, thanks very much for the invite and for giving me the chance to contribute to this webinar. On the mismatch between things like BECS and the limited spillover, at least on technology, I think that a lot of that comes down to the fact that the way in which BECS tends to be handled in the research is usually quite model-based and usually quite, I mean, I've heard BECS being described as a proxy for all sorts of removals, especially in the context of AR5, for example, IPCC's AR5. And therefore not that much of the research actually being based on the technology, more based on what the carbon budget effect of deploying BECS at scale might be, which obviously isn't quite that useful when it comes to innovating on the technology itself. At the same time, BECS is also heavily reliant on CCS, on which perhaps the CCS research isn't captured in this technological spillover research. I'm not sure, but in any case, the concept of BECS tends to be addressed more as the kind of figurehead for removals more generally. In terms of other sort of mismatches, I think there's often quite a difference between what is being discussed at the political level and what the research is saying, and the risk of sort of picking a particular technology here. One of the discussions that is ongoing is the methodology for biochar, for example, where in political circles, the discussion about the permanence of biochar is often framed as having been settled, whereas in the scientific research, it doesn't really seem to be that. It doesn't seem to be understood in that way. And there seems to be quite a mismatch between the way in which there's a sort of desired understanding of what the research is saying versus what the research is actually saying. And I would say it often comes down to whether or not a narrative makes sense or is appealing, rather than whether or not the research is robust and is making a clear case for a particular policy recommendation or anything. And unfortunately, I think that's quite a common trend in political circles, especially in Brussels, which is quite a complex political machine.
Yeah, I think what you were just mentioning also sort of risks or carries the risk of, breaking trust, I guess, to some extent, which we know is actually essential for the development and the deployment of novel technologies. So what's your sense? How can we best sort of build trust at the science, policy, society interface for CDR?
Well, I think a lot of it is about, well, very similar to what Christina said. So transparency, I think, is super important. I would say it's really the most important part of this. One of the big issues with CDR and with all of the technologies associated with CDR, or possibly even not necessarily just technologies, but also for the more conventional methods, is the hype that tends to be generated around what it can or cannot do. Often we see extremely inflated values in terms of how much might theoretically be removed. And we often see, you can often tell how bullish a sort of entity is based on which number they cite from the IPCC reports. The range is enormous. It's between 100 and 1,000 gigatons between now and 2100. And very often we'll see the 1,000 gigatons number mentioned, which is very much the extreme end. And I think there's very few reasonable papers that would suggest that 1,000 gigatons is remotely feasible. So there's quite a trend towards trying to hype the potential that some of these efforts might be able to generate. But you know, one of the clearest examples here is the recent news involving Climeworks in Iceland, which I'm sure some of you will have seen, that basically the two pilot projects that, well, I guess the most recent pilot project that Climeworks have launched, the Mammoth plant, has under-delivered quite substantially based on what they initially stated. So has a nameplate capacity of 36,000 tons per year, and they seem to have only captured somewhere around 800. And I think, you know, it's a bit unfair. The amount of media criticism that Climeworks have received for this, I think, is a bit unfair, in the sense that, you know, it's unfair to expect a novel technology to deliver the way that we want it to deliver, especially if it's brand new and if it's the first of a kind. And at the same time, you know, perhaps Climeworks should have been a bit more sensible in their projections or in their communications in terms of what they would be able to expect. I think they've done a very good job of being quite transparent on their website about, you know, they have a nameplate capacity, and then they have the emissions associated from the energy use and from the construction and all those things. I think they've done a great job of being transparent on those things. But they need to be a bit more realistic in terms of what they can actually deliver. And I actually think a lot of the responsibility for the hype doesn't necessarily come from the technology producers, suppliers, whatever, because they're really trying to just figure out how to make this work. I often think most of this hype actually comes from market actors that kind of see CDR as a potential, not quite silver bullet, but at least cheaper get out of jail card than cutting their emissions. And not to say free, because nothing's free, but effectively trying to find a way to outsource their climate responsibilities to someone else, even though it's been made abundantly clear again and again and again that the removals that we generate need to be on top of every single bit of emission reductions that we can generate, and that they will be needed for residual emissions specifically. So that's, I think, where I'd put most of the blame is really on the market actors that are egging on this hype.
Yeah, an important point also on sort of the challenges between creating some level of hype to help those methods get off the ground, while avoiding sort of over-promising and inflating sort of expectations. Thanks a lot for those reflections, Mark. I want to turn now to the questions that have been coming in our Q&A, and I'll just start at the top. And that's a question for Francesco, but maybe also Christina wants to take it, given their work in Brazil. And this person asks in regard to the geographic concentration that you found of CDR research and deployment. And they are asking, how might this reinforce or challenge global inequalities, and what are the consequences for climate change mitigation?
On my side, I think we have to be very careful in analyzing this, because especially on some of these more novel technologies, especially DACs, where and how and from whom those will be actually fully developed and maybe deployed can generate a shift in the way we approach, on one side, mitigation as a whole, and on the other, it can generate a shift in how we think about the CDR strategy when it really comes to deploy. Because my feeling is that for these kind of technologies, and DAC in particular, there is a lot of concentration of research in the global north, but it's not fully sure, despite the few pilot projects that are around, where exactly the deployment that one might need in order to achieve ambitious removal over the century will actually take place, and through which sources of energy. So to me, this could induce a fight for land, both for energy generation and actually deployment of the facility, which may have consequences for who is actually, let's say, financing the removal and benefit from the offset, and who is hosting the facilities. To me, this is still totally non-trivial. On the other side, I see the Global South more specializing on more conventional, let's say, nature-based solutions, which I tend to believe it's sort of natural. I mean, some of the companies now working on DACs, for example, they're spin-off with universities, or they are quite linked to academic research. So it's relatively natural that this can happen. But this also create an issue with their possible strategies, because we know MRV, it's more complicated for them. And so this can create an additional issue when it really comes to integrate the different solutions within, for example, the same market at scale. So those are elements that I think we really need to take into account. And what I found peculiar, and we were not able to really understand why, is China. China, on all other green technologies, really specializing on the manufacturing capital-intensive part, not for negative emission technology. So negative emission technology, China is specializing on, let's say, nature-based method. And this was a bit surprising for us, and we could not really find a convincing answer for this.
Thanks a lot for this comprehensive answer, Francesco. Christina, did you want to comment on this aspect as well, given that you're working sort of in context across South America, Europe as well?
Yes, so we are both a Brazilian and European company, but we deploy only in Brazil. I think something I would like to highlight, I think especially in enhanced rock weathering, is actually we go to Brazil to learn. Because interestingly enough, Brazil has a very long history of working with rock powders in agriculture, so basaltic rock powders in particular. And although they've been researching this for a long time, it wasn't specifically intended to be for carbon dioxide removal. It was more about food security, about replacing imported synthetic and chemical fertilizers. But actually, the use of basaltic rock powders dates back all the way to the 1950s in Brazil, and there's a huge wealth of literature on how to use these safely, how to use them effectively, where you get the most benefit. A lot of that literature is also in Portuguese. So I don't know for this study whether or not it crossed different languages when you looked at papers, but often when we look at literature, we mostly only look at things written in English. And actually we, as a company, like I go to Brazil and talk to people to learn about what they've done and to improve what we're doing. So I think that's just something to bear in mind, is that although it looks like a lot of stuff is coming out mostly out of the global north, actually we have a lot to learn from the global south as well.
Yeah, that's such an important point. I want to take one last question before we wrap it up. And the question is again directed at Francesco, but if the others would like to express as well. And the question is, what are the underlying assumptions about economic growth and technological optimism in the analysis that you presented? The person says, it seems like the study implicitly assumes that technological innovation, like patents, will seamlessly translate into viable CDR solutions. Do you have any thoughts on that question, Francesco?
Yeah, thanks. There are no a priori assumptions about economic growth and the direction of economic growth or the direction of technological progress. I believe that for some of these technologies, some of these, let's say, methods, not really technology, because then it really depends on how we define a technology. But for some of them, this linear model of innovation that has been used historically to characterize technical change in the manufacturing can still work, meaning that in order to finally deploy the technology, what you really need to do is to start from research and then move to prototyping, testing, and gradually upscaling. So it's not that being able to connect science to patents, so science to technology, delivers a viable solution. But for some of these technologies, I tend to believe DACs in particular, but also BECS, this is one of the necessary steps. As also Christina was mentioning, possibly for other solution, like enhanced weathering, it's not really this the direction. And maybe in this case, it's more important to have, let's say, science to science spillover. So to be really able to develop methods and procedures to actually monitoring and reporting the actual removals, and this will be captured by only part of our analysis, and then the science to technology might be relatively less important there. So it's not that what the articles try to conceive is you need all of these positive spillovers in order to deliver a viable solution. But for some, I think you need, and again, in BECS, we find a sort of incoherency, a failure. For DACs, not.
Yeah, thanks for adding nuance on that point, and also on different sort of pathways, I guess, to impact across those different dimensions. Christina and Mark have both been busy answering questions in the Q&A directly. Thanks so much for that. We've answered all of the questions, and also we are at the end of the hour. So I want to thank you all for your participation. Thanks, Francesco, for the presentation, and Mark and Christina for sharing your reflections and thoughts. Thanks, of course, also everybody for tuning in and for actively engaging in the chat. And with that, I'd give back to Sohail to wrap up the webinar for us.
Yeah, thank you, Livia, and panelists. It was great hearing your thoughts. Thanks for your time, and thanks to everybody who attended the webinar. I just wanted to mention again, because some of the questions may need the follow-up. The best way is to interact with us through the platform that I mentioned. You can also Google and find it. It's CDR Uptake Stakeholder Forum. So if you search for that, you will find our platform, and you can join, or you can see our activities and get in touch with the members of our consortium. And we will post the recording of this webinar also on YouTube. So, and the link will be shared through the platform, so you will be able to watch it again if you missed something. Having said that, I would like to invite you for the next webinar, which will be in July, and looking forward to that. Thank you, everybody, and have a good afternoon. Bye.
Thanks, everyone. Bye.
Thanks, everyone.
Bye, everybody.
Thank you.